This conference will now be recorded.
Very good morning, students.
This conference will now be recorded.
Very good morning, students. So today also we'll continue discussions on ray optics. Yesterday we had taken POIQs from NEET-UG papers, most recent papers. From there we had discussed numerical problems on ray optics. Today I have taken few questions on ray optics from JEE Mains paper, mainly all the most of the questions are from JEE Mains 2022. So this we are doing because ray optics seems to be a little bit tricky for the students when they go for exam and they are afraid of this topic. So I thought I'll discuss some PYQs both from NEET-UG papers and JEE Main papers on this particular topic. So we had discussed few questions yesterday. Today we'll continue with some more questions, and tomorrow also we'll continue with this ray optics. So let us start our discussions today. So this question is saying that two identical thin biconvex lenses of focal length 15 centimeter and refractive index 1.5 are in contact with each other. Biconvex lenses means this. Okay, so two biconvex lenses are in contact. Okay, identical. Okay, they are identical in the sense their focal length same as 15 centimeter given here, and refractive index also same 1.5. So both are made of glass. The space between the lenses is filled with liquid of refractive index 1.25. You can see that the focal length of the combination you have to find out. So dear students, we have discussed some questions yesterday like this. So let me draw here. If the liquid is filling this space, we have this combination now with three lenses. One is this, then the middle one will be this one. Okay, so this lens is made of the liquid itself. Okay, refractive index of the material will be 1.25 for this lens plus another lens, right? So these three are in contact. So focal length of this is suppose f. So this is also f. I have to find out what is this f prime. Okay, so as you know, we'll be as usual using the lens makers formula. Okay, lens makers formula. So in this case, look, this f is given, right? So actually f is what? Let us see. This is actually 1 over f is equal to, because I have to find out refractive index of this in terms of f only. So because radii of curvatures are not given. So 1 over f is equal to mu minus 1. This will be 2 by r. I'm not writing again. So this will be 2 by r. I'm just taking by default the radii of curvature of biconvex lenses are the same, and as you know, 1 by r1 minus 1 by r2. R2 is always minus, so that's why it will be 2 by r. Let us take that. And here it is 1.5, so 0.5 into 2 divided by r. Okay, that means this is 1 over r. Okay, in case of this, so this is also actually both side concave. Okay, this is both side concave, biconcave lens. So refractive index of this biconvex lens is, see, 1 over f prime is mu minus 1. That means 1.25 minus 1. Okay, divided by, see, this r1 will be negative and r2 will be positive. So this will give you actually, see, if both are the same, then I have r1, 1 by r1. That means 1 by r with minus sign. This is plus, and r2 will be actually positive, but here in the middle there will be negative sign. Okay, r2 will be positive, but middle there will be negative sign, so this will give you minus focal length, as you know, so minus 2 by r. So look, this I have got here 2.5 into 2 by r with a minus sign, so that I am not considering here. Let me find out the relation between this f and, so here actually f is equal to r. So in this case, see what we are getting, minus 0.5 by r. So if I multiply with 2 in the numerator, in the denominator, so I get 1 over 2r. Okay, so 1 over r is actually 1 over f. That means, you know, f prime is going to be 2r. 2r means actually it is 2f. Right? Now things are okay here. So I have got all the, so this will be actually with a minus sign, minus 2f. Now let me tell you, see, in combination we know the power is actually 1 over f, and that is equal to this equivalent. Okay, power 1 by f1 plus 1 by f2 plus 1 by f3 for 3 lenses. So these 2 lenses will be having the same focal length. Let us say f is given as 15 centimeter. So let me just do one thing here. I'll write 1 over 15 centimeter minus, this is 1 over 2f, that means 30 centimeter, and this is again 1 over 15 centimeter. Now this is 2 minus 1 plus 2, so what I get, 3 by 30, that means 1 over 10. So equivalent focal length will be 10 centimeter. Let me, okay, so this is of integer question. Okay, so positive integer question, so this is actually the answer. So the 10 centimeter will be the focal length. Okay, focal length of the combination will be 10 centimeter. Okay, so this is how we have to solve this problem. This kind of problem we have solved yesterday also, so I hope you have understood now today better again. So let us go to the next problem. So this problem says a convex lens of focal length 20 centimeter is placed in front of a convex mirror with principal axis coinciding each other. Okay, the distance between the lens and the mirror See, I'll just show you pictorially the situation. The situation is like this. Suppose this is my principal axis, this is my convex lens, and I know the focal length of this to be 20 centimeter, placed in front of a convex mirror. So I have another, okay, so this is the mirror, convex mirror. As you know, this side will be polished and this side will act as, the convex side will act as a mirror. Okay, and it is said that the distance between the lens of the mirror is given as 10 centimeter. I think I have drawn it is too far. Let me just do one thing. Let me draw this lens little nearby. Okay, 20 centimeter, and this distance is actually 10 centimeter. Now the question says a point object is placed on the principal axis at a distance 60 centimeter from the convex lens. So from the convex lens, a point object is kept at 60 centimeter from the convex lens. So this is 60 centimeter. Okay, so I have a point object over here. The image formed by combination coincides the object itself. The focal length of the convex mirror is how much? See, in this case, you have to understand how the ray which are getting reflected by this mirror are going to be retracing the path. So what is the situation when the ray retraces? See, if I take even a plain mirror, you know, path will be, see, the reflected ray will be retraced the path when there is a normal incidence. When there is a normal incidence, okay. So in this case also, in case of convex mirror here, if the ray which are getting refracted passes through the center of curvature, somehow. See, if I draw this figure like this, suppose, okay. So I'm just taking two A's. Let me do like this. See, after refraction, if the rays okay, let me just change the position of the center of curvature itself. Let us take, okay, this is center of curvature. See, so the ray has to actually pass through the center of the curvature of the mirror, okay. Then only there will be retrace of path. I'm sorry, I'm not able to draw it properly. Let me try once again. So like this, and it has to pass like this, okay. So let me take this, okay. So this is the one. So look, if this ray after refraction passes through the center of curvature of this mirror, then it is actually reflected back or tracing back the same path, because center of curvature is perpendicular to the, like, center of curvature. The ray which is passing through the center of curvature will be always perpendicular to the surface of this mirror. Okay, so at this situation only there will be image formed at the same place as the image, object itself. So first of all, let me find out what is the position of image. I know u is given as -60, f is given as 20 centimeter. Then what is v? What is v for the image formed by the lens? So that we have to find out first. So we know 1 over f is equal to 1 over v minus 1 over u. So 1 by v I have to find out. So 1 by v is equal to 1 by f plus 1 by u. So here 1 by f is 20. This is 1 minus 1 over 60. So it will be actually 30, isn't it? So 1 over 30. So v we are getting as 30 centimeter. 30 centimeter. See, already this much is 10 centimeter. Okay, this much is 10 centimeter. So this much must be 20 centimeter again, right? So what you have to find out? You have to find out the focal length of the convex mirror. We know focal length and the radius of curvature has got a relation r by 2 is equal to f. So from the pole to the center of curvature, this distance is r. So r is 20, so f will be 20 by 2 centimeter. So that is actually 10 centimeter. So this will be 10 centimeter. All right. I hope you have understood this. All right, we'll go to the next problem. A ray of light is incident at an angle 60° on the glass slab of refractive index square root of 3. After refraction, the light ray emerges out from the other parallel phase and lateral shift between incident ray and emergent ray is given. Then you have to find out the thickness of the slab. See, this is related to a lateral shift of the rays. So here you look, this is the lateral shift. Okay, lateral shift. All right, so if this is T, then we have got a formula for lateral shift. Okay, we'll directly write the formula for lateral shift. So what is that? The formula says L lateral shift. Okay, so I have to find out the thickness suppose D, and this lateral shift, let us say this is L, and this thickness is T. Okay, this thickness is T. I have to find out that L is given, so this lateral shift is given. Okay, lateral shift is given. So what is the formula for lateral shift? So formula for lateral shift is given as L is equal to T sine angle of incidence I whole into 1 minus cos of I divided by mu square minus sine square I. So this formula you have to remember, otherwise things will be a little difficult to come up to this formula. Okay, so now you just put the values. Okay, what is t that you have to find out? L is given as 4 root over 3. T I have to find out. Sine I is sine 60 degree. 1 minus cos of 60 degree. Mu is given as root over 3. That means this is 3 minus sine I. Sine 60 degree means how much? Okay, sine 60 degree square or sine square 60 degree. So I have, see if I write this, sine 60 degree is actually root over 3 by 2. 1 over cos 60 degree is half. This is square root of 3 minus 3 by 4. Okay, and see this I get, see this will be, okay, let me just do it, root over 3 by 2. This whole thing is, so this 2 will be there in the numerator, so this will be actually 2 into, this is 9, 9 means 3, so this is 1 over 3. 1 over 3 means 2 by 3, so 3 by 2 into 2 by 3. Okay, so this will be t by root over 3. So we have got t by root over 3 is equal to 4 root over 3. This implies that t will be 12 centimeter, and this is actually the answer. Okay, so 12 centimeter is the answer. So here I'll remind you that you must remember this formula. L is equal to t sine I whole into 1 minus cos I divided by root over mu square minus sine square I. So if you know this, then things are done. Okay, now let us see the next problem. This is also a very interesting problem, but not very difficult to solve. Let us try that. So what is this problem saying? It is saying that the difference of speed of light in two media A and B. So there are two media A and B. The speed, corresponding speed of light in the media are BA and BB, and their difference is given. BA minus BB is given. That is 2.6 into 10 to the power 7 meter per second. The refractive index of the B medium is given. That means mu B is given. What is that? 1.47. Then the ratio of refractive index of medium B to the medium A. That means you have to find out what is medium refractive index of medium B by medium A. This ratio you have to find out. Okay, this is the question. So this is very simple. If we know the definition of mu B, let us, or mu, what we know, mu is equal to refractive index is equal to C by V, right? C by V, that we know. Then let us do one thing. We can actually divide both sides from here. look, I'll just divide with C. I'll divide this with C and this also with C. Then what I get? This I get 1 over mu A minus 1 over mu B, and that is see 2.6 divided by 2.6 into 10 to the power 7 divided by 3 into 10 to the power 8. Okay. Now further what we can do, we can actually we have to find out mu A by mu B. Let us multiply mu B on both sides. So mu B by mu A, and here it is minus 1, and this will be mu B into this factor 2.6 into 10 to the power 7 divided by 3 into 10 to the power 8 meter per second. Now look, this mu B by mu A is equal to 1 minus, see, I know this, I can actually do this 1.47 into this is 2.6 divided by 30. Okay, this I can write, isn't it? Or we can do one thing, we can see, I can actually multiply this two factor. Okay, so after multiplying, what we will get, 2.6 into 1.47, so this will give you, see, this will be 30 minus 3.822. Let us go up to second decimal divided by 30. Okay, so 30 minus 3.82 will be nearly 26. So let me then divide 26 by 30. Okay, so this is, I see plus, actually this will be plus, so that's why the problem is coming. Anyway, so this will be positive then. So this is 33 divided by 30, so nearly 33. Let us do that itself. 33 divided by 30, so this will be 11, this is 10. So actually we can just take this as 34 nearly, so that will help you to get the proper factor over here. So you look, okay, so if I do this also, 1, so 1.1 you have already got, so 1.1 you are getting. If you just do it 4, look, you will get actually 1.13. 34 by, so nearly 34 by 30. If you just do this division, you will get 1.13. Okay, so this was also very simple question, just sake of calculation, not more than that. Okay, all right, now this question is again very simple question, but we have to understand what we have to find out here. The question is saying that the light travels in two media, M1 and M2 with speeds, different speeds. Okay, these are given. So you look this medium 1, medium 2, the speeds, from the speeds you can understand that if this is medium 1 and this is medium 2, so this is actually denser medium, denser, and this is rare medium, because the speed is greater in the rare medium. Okay, the critical angle between them. Okay, critical angle. See, when a light ray passes from one, okay, so one medium to another, so denser to rare and medium, you know, at the critical angle what happens? So suppose this is theta c, critical angle. At critical angle, angle of refraction will be actually 90 degree. Okay, so what we can write from here? We can write, so this is denser medium. Let us take the refractive index to be 1. So sine n1 sine theta c is equal to n2. This medium has n1, this is n2. So n2 sine 90 degree. So what I get, sine theta c to be equal to n2, that means refractive index of the rare medium divided by refractive index of the denser medium. Now look, see, refractive index, I know this, I can actually make as c by v2, that means, yeah, speed through the rare medium, and c by v1. So actually here things are little interchanged. Yes, this is fine, this is fine. Okay, so here you look, this is v1 by v2. So v1 is how much? v1 is 1.5 into 10 to the power 8 meter per second, and v2 is, see, n1 is actually denser medium, yes, so that's why speed is less, and v2 is given as 2 into 10 to the power 8 meter per second. So this 10 to the power 8 will cancel each other, so this will be actually, say, 3 by 4. Okay, so what I get, 3 by 4, sine theta c is equal to 3 by 4. So sine inverse 3 by 4, actually theta c is equal to sine inverse 3 by 4. But see here, among these options, none of this is matching with sine theta c, like sine theta c with this. Okay, given options. Let me just do one little trick over here. So I have got sine theta c is equal to 3 by 4. Okay, so I can write, see, there is an option with tan theta. Let us see how tan comes. Since I know the sine, I can actually write sine, say, tan theta c is equal to sine over cos theta c. Sine theta c, I can write 3 by 4 over here, and here it is 1 minus sine square theta, that means 9 by 16. So this will give you 3 by 4, here 4 divided by square root of 7. This 4 cancels each other. This is 3 by root over 7. That means, you know, theta c is actually tan inverse. In terms of tan, you can write as 3 by root over 7. Okay, so look, this option A will be the correct answer for this question, right? Now let us go to the next problem. So this problem says a microscope was initially placed in air of refractive index 1. That we know, refractive index of air is 1. It is then immersed in oil of refractive index of medium. See, oil has refractive index 2. For a light whose wavelength is lambda, a light has been used for which the wavelength is lambda. Calculate the change of microscope resolving power due to oil and choose the correct option. So resolving power will be 1/4 in the oil than it was in the air. Resolving power will be twice in the oil than it was in the air. Resolving power will be 4 times in the oil than it was in the air. Resolving power will be half in the oil than it was in the air. Okay, this is actually the question. We have to find out the refractive index, resolving power in the oil in terms of resolving power in the air. See, resolving power has got a formula. I'll tell you. Resolving power is, for a microscope, 2 sin theta divided by 1.22 lambda. Okay, if this is in air, so I can write that as air. But here now, this is actually RP. We have to find out 2 sin theta. So these angles are not going to change. 1.22 lambda oil. So this is the only change we have to incorporate here. Okay. So lambda air is actually lambda. It is given. Wavelength of light in air is lambda. So that we can write as lambda itself. So this is in air. Okay. I have to find out in oil. So this lambda oil I have to find out. What are the things given? Refractive index. So I have to actually replace this refractive index, this lambda of oil in terms of refractive index, right? We know refractive index mu is equal to C by V. Okay. So C is the speed of light in air. If I know the frequency, then n into lambda. And one important property of light is that it changes its wavelength, but it does not change frequency in different medium. Okay, so in this oil medium also refractive index, this frequency of the wave will be the same, light wave will be the same, whereas the wavelength actually gets changed, that will be oil. Okay, so this n I can get rid of from both sides, like numerator and denominator. Now I can find out, see, this lambda oil is equal to lambda, that is in the air, divided by mu. Mu is the refractive index. So let us put it here. See, if I put it here, what I get, this particular part is remaining the same. 2 sin theta divided by 1.22 lambda oil, I'll write lambda divided by mu. Mu I can write in the numerator. So this part is actually refractive index, resolving power in the air, RP in air, and refractive index of the oil is given as 2. So the resolving power will be actually twice resolving power of the microscope in air, in oil, will be twice in the oil than it was in the air. Okay, so option B will be the correct answer for this question. Okay, so we'll go to the next problem. Okay, so this problem, okay, so I think this is the concluding problem for this session. So what is this problem saying? This problem is saying that a light ray is incident at an angle theta 1. Okay, so suppose this is theta 1, having see this two plane mirrors. So you can see these are two plane mirrors. They are kept at an inclination 75 degree, and this system a light ray is incident at an angle theta 1. This is the angle of incidence, theta 1. Okay, theta 1. This is, so this will actually come out as theta 1, right? Reflected from there as theta 1 here. Okay, so after reflecting from mirror 1, it gets reflected back by the mirror M2 with an angle of reflection 30. So let me draw the normal over here. So normal will be something like this. So this will be reflected at 30. Okay, actually, yeah, so yeah, somewhat like this. Mirror, it is perpendicular, is not exactly there. Okay, this is horizontal only. Okay, fine. So like this. Okay, then it goes like this. Okay, so this is also 30. Then if the angle of reflection is 30, so this will be 30. So you have to find out the total deviation of the ray will be dash in degree. Okay, so total deviation is actually the angle between these two rays, this one and this. What is the total deviation? So theta 1, this is 30, 30, 60. Okay, if you draw back this way and you have this one. Anyway, see, this can be solved geometrically, but it is very easy to remember a simple formula in case of this this plane mirror. If they are kept at an angle theta, then the ultimate reflected ray from the second mirror will be deviated from the incident ray by angle delta, and that is given by 360 degree minus 2 into theta. What is theta? Theta is the angle between the mirror. So here in this case theta is 75 degree. So 2 theta will be actually 150 degree. So this will be actually 210 degree. So what is the deviation here? 210 degree. 210 degree will be the deviation. And this is very, very simple to remember. Okay, better you remember this, otherwise also you can do it from this geometry if you are properly drawing the geometry, and you can do in that way also. Okay, so to save the time, I would suggest you to remember this. When there is an inclination between the plane mirror is theta, then this delta, the deviation of the angle of deviation or the total angle of deviation between the incident ray and the reflected ray will be given by delta is equal to 360 degree minus 2 theta. Okay, so from there you can find out this angle of deviation. Okay, so with this I'll stop it here for today. So this question was actually also from JEE Main 2022. Okay, so it was also from JEE Main 2022. All right. So thank you for your patience. Bye for today.